are highest priority. And for added information, you are able to specify the stage of the task so other team members can see the progress. Tasks can be created in Altium Design directly from the comments and task panel as well as from a comment. They also be created from the workspace in your web browser. Tasks are organized in a board to for a quick access and viewing. And what's nice is that this task can be easily moved from one column to another with just a click and drag. Let's see how this will help you inside the Altium Design with a small demo. Here I have opened the Altium Designer. The current version is now 23.0.1, and I have connected to my workspace, and you can see the project, and you can access this comments tab. From there, you can able to assign the task. Just click on this comment, and this here the component is missing. Just place here and just mention, and you can assign to a person whom you want to assign. You can assign, and you can click on this bar button, assign task, and you click on this button to specify some graphical representation to make him understand better, and then post. Before posting it, you have to make sure the project is shared or not. If not, it will ask you to share. You can able to specify the view or edit. Just click on share. That is very important. Once it is shared, now you can see the project is shared and assigned to this person, and he will be getting a notification of this comment, and you can directly click on open the browser, and you can directly sign into Altium 365 with his credentials, and you can look into this thing, and you can set the priorities highest, high, medium, low from here, and then here also we can able to change the status of the this particular comment to do in progress or resolved, and we have other option. You can able to even copy link and share him through chat or other means of communication used to quickly pay attention, get attention by your reviewer. You can also do this, and if you click on this particular uh, comment, it will automatically take to the browser. Then you need to sign in with your, just like you sign in, it will directly open the project in the workspace. Yes, you can see here, it's been saved here, and you can see the comment is being specified here. This particular component is missing. It is been, and if you go to task here, you can see the task being assigned by me to this person. You can see here the level you can do to do in progress. That is all you can able to change the progress of your project. And then this is a project level task management, and also you can have the account level project management, task management as well. If you go to the task here again, you can see what and all task has been assigned for all the project of your workspace can be seen. On the above, you can create a new task. This is called the account level, the project workspace level task. Okay, and you can just specify in progress to do, or if you want to, whom you want to assign, you can able to specify the name, and you can able to specify the target, and then you can see here it's been assigned. You can able to change the status from to do to in progress or complete, like this. You can able to manage the task in terms of project level as well as the workspace level inside the RTM designer with the new features and capabilities. Okay, now let's go back to the presentation. Now let's talk about the difference in files and comparing those files. Engineer file comparison Altium file allows you to compare your Garbus, BOMs, and PCBs and schematics from different server commits. The comparing system is electrically intelligent and know not just a change was made, but what changes were made. It will tell you If you have added or deleted comments, nets, or anything else, this is available both in web browser and Altium Designer application. And being able to compare your files to one another is very useful for debugging. You can quickly find any problem areas and then fix the problem, or you can revert back to your working version of your project. Okay. Now let's see this in action. Let's go back to the Altium Designer. Let us for this project. I'm just going to open a new, project here, and in Altium for the comparison, we have a history panel from where you can see the all the commits and releases of your project from the starting from the end. You can see each project and commit. And the same way, you can also have a glance this project in the web browser, where you can able to see the same kind of history like we seen in the Altium Designer. You can, if you go to history panel, you can see the all the history of the project. And here you can able to compare your commit with the previous commit with the latest commit, and also you can also compare with your previous release with the latest release. Now let us see. I want to do a comparison with this release with the previous release with respect to Gerber. I can select the release from the down. I want to select release of version 2. I want to see what is the differences we made between the release 5 and release 2. You can see here is the what the changes we have found. This is the version 2 Gerber how it looks, and this is the version 5 Gerber how it looks. We visualize here by layer. And when you see comparison, this is the difference it found with reference to the uh, version 2 to version 5. This is version 2 and this is version 5. This very small changes in terms of component placement. That it is there is no much difference we can see in terms of this other ways. Okay, that is you can able to easily and quickly compare your carbon and tool will tell you the difference within no time inside the anti part. And also we can do the comparison between your schematic sheets as well. Like we can able to do the comparison to schematic sheet to the previous commit. And if you want to do the Gerber comparison, is only possible from the project user. Now I will see a list between this version and the version of again the second version. I just select here again to open a comparison window, and it show the what and all modifications. This is the proper component has been modified. I mean the value has been modified, and then there is the one where the value of this register has been modified, and there is a new capacitor has been added, and this is the where the changes found. The ground net has been extended further. Okay, like this comparison will help you to quickly and easily understand what are changes we have done to your project with the previous release. Okay, see how easy and how quickly you can able to find the your comparison report. Now let us go back to the our PPT. We'll go talk about the custom pad shapes. In today's devices, we use a variety of components, including those with special requirements like pads with complex or let's say non-standard shapes. Now, Altium Designer is able to quickly adjust to these non-standard pad shapes. You are able to create these pad shapes by converting place regions or a closed outline, or directly by using the shape dropdown from the properties panel. In the properties panel, you can also toggle on and off thermal relief and rounding of rectangular pads. To simplify a complex design, you can break it down into a more digestible logical blocks, and even within each of these schematics, 20 blocks, you can continue to break down your circuitry into most basic building blocks. With Altium Designer and Altium 365, you are able to do just that. You can save circuitry from one design and then share that with your entire team. And this circuitry or use block can be used for schematic and layout. So for the next time, you need to create some sort of schematic. You can place your different circuit blocks and build out a schematic very quickly. These really are a time saver, not just for the initial placement, but also down the line if you have to do some debugging because you know that the use blocks you're placing has been approved and works. Now, typically IC decoupling, power counters, typical IC pinouts of connectors, common PCB labels, present of mechanical components, save time on developing and debugging, reduce probability of wrong resistance, simplifying purchase and logistics, simplifying warehouse management, and it will actually increase the efficiency of device development works in unthinkable without using what you have already have. The design use panel is designed to deliver these benefits. Use blocks are now linked fragments of the schematics and topology. And now we can bind several types of routing to a single schematic fragment, which greatly extends the possibility of working with repeated solutions. Now let us see this how these use blocks will help in using your circuitry. Let us have a demo on this page. Now let us have a different project to explain these reuse blocks. Here I have a project which will be a AC to DC converter. Now I just show you how we can reuse this circuit in building the reuse design reuse circuitry and how we can able to place it in a new project. Let us see. Now let us copy this circuitry. This circuit I don't want this converter. I just want this process section. I want to have this. And then we just go to panels and go to design reuse. And you can see here you can able to manage your design reuse locally or in the workspace which you are connected. And just click on this plus symbol, which will create a new reuse project, which will be getting a schematic and PCB, which will be getting a project which will be directly going to push in the cloud. You can see here. And then now copy this and then the schematic sheet, the reuse schematic sheet, just paste it. As here, I don't want this inductor, transformer, this transformer, I don't want this. Let us delete this. Okay. Now we are done with the copying the circuitry. Now let us go to the PCB part where we want to have the placement. Now let us open the PCB where you want to copy, and let us do the same selection again. So it will be getting copied. Yes, this is copied, and we don't want this section. I think yes, this is not copied. Yes, this is not copied. Now let us say copy and then go here and then paste. Let us not, we don't want this component. Let us delete this. Okay. Now, once this is been done, we need to sync this schematic with this. I mean, the component to be linked. For that, go to project and do component links. And here I'm going to use this option, add paste match by designator. Just click on this, automatically whatever components are matched with the schematic and PCB or get mapped. Just click on perform update. Now the components are successfully made linked. Now we need to get the synchronized between the schematic and the PCB. Now let us use this option to import the connectivity between the schematic and the PCB. Now we have done this job. Let us close this. These two are not required. Now under project, let me close this one also, which is not required. Yes, under project now we need to save this. Let us save this one and save the server and just give some meaningful name. Just can just give me sample demo circuit, but you just give what is the functional of circuit. You can just make sure mention properly and just create description also if required to explain to your colleagues the functionality of circuit. If you have description, you can enter. Just click on OK. Now this circuit will be pushed as a use block to the our cloud workspace. Yes, now it's been successfully pushed. Now let us see how we can reuse our circuit. Now let us create a new project. Here, let us give some meaningful name and then click on create and then add a schematic and same way add a PCB and then properly save this project, which is very important. Now we will access that reuse option from panels and design reuse, and you can see here all your circuits. See here, this is the one which we have created by me, and I can click on here and say place the circuit. You can see the same circuit is being placed from there, and then go here and in order to place the PCB, the reuse block, what you did, just go to design and then import changes from the project. You can see all the exhibit changes, all the component net names will be added. Just see here, all the components got verified. You can see the no errors. See, this circuit is being pushed. This site can place it on the location where you want. Maybe okay. Now you can place circuit where you want. Okay, this all you can be able to use a new functional design to use, where you can able to create your reusable circuits and store in the cloud or locally, and then can reuse whenever required. And uh, there is a way you can also independently reuse schematic circuits, and we can also create a reuse blocks independently for PCB circuits as well. Now let us go back to the presentation. Let me close this. Let's go back to the presentation. Now let us talk about the multifunctional pin naming. Sometimes components have multifunctional outputs for using different operating scenarios, and what it was not really possible to put all these functions or names on a single pin while still maintaining clarity. Until now, in Altium Designer, it's not possible to define multiple names for multifunctional pins in your designs. From the properties panel in a schematic, there's a new function field. From here, you can enter a custom name for a pin, which then gets saved as a tag. And you can name your tags whatever you want, including special characters to apply the new function to a pin. All you have to do is select a pin schematic and then choose the new name from the pins tab in properties panel. Let us take a look how this works with a quick demo. Now let us take example of this IC. We want to include some. Let us assume we have a multifunctional pins in the of IC. How we can define? Let us go to the pins and you can take any pin which you want to assign. See here already I have assigned some multiple pins. Now let's take another example how we can assign the multiple pins. Let's click on edit. Now it will open the edit panel. Here you can able to enter the multi-functionality of this IC. Even you can enter the text with a special address as well. And then click OK. From down you can choose what is the type of the field you can able to assign like this. And from here also you can select and you can able to choose which one to be displayed or all you want to get displayed. You can also specify the same. This is locally we are editing. You can also edit the same from the library. So the component, if the component you have managed in the library, let's go to part actions and you can able to edit this component from the your cloud, because this we are editing locally. If the component we are using from the cloud workspace, they are also able to add the multi-functionality support pins you can also enable in the during the component creation. Now let us go back to the presentation. Now let us take a look at the length tuning to relate to target. Most high-speed interfaces contain parallel buses that operate at high frequencies, and for proper operation, it is necessary to accurately match the lengths of the group of signals. Oftentimes, this length matching must be associated with a timing signal, and now with Altium Designer, you are able to tune your signals related to source target. This can be easily set through the design rules. So let's take a look at how we can able to match your length with a associated length of a net with this small tab. Let us close this. Now let us open this mini PCB, and we are going to open this is my project. Let us see here we have a DDR4 and we have a FPGA. Here, if you take a look at the schematics, we have a U14, which is connected to the U1. Now we want to have a length tuning with a way to length of a associated net inside the PCB. Let us take a look. If you go to the panels and PCB, and you can see here, yes, this one U1 and U14. This is the IC where you are focused. And you can see which we want to do the length tuning of this particular length as it's not been routed and the length is mismatching. We want to tune this net length way relate to net where we need to set inside the design rule. For this, go to design rules, and then under high speed, go to the matching length rule. And you can see the matching length rule between DDR4 1 and 14. We have X signals between this U1 and V14, and you can able to specify your source target from the drop down. It is DDR4 A3 underscore PP3 is my source target. Just apply and OK. Just let's see for that DDR3 A3 PP3. So this is the R target. You can see this is the target for the RNet DDR3. This is the RNet. Now let us do the routing. This is just to a single layer mode. Now let us do the interactive routing of this particular net. In layer 5. This is the net. The tuning. Now we can do the glossing of this net. We have fine tuned based on the space availability. Now we want to do the length tuning with respect to a net what you have chosen. Just pick the interactive net length tuning, and they can able to do the tuning of the net. Okay, by this space we're going to get the different patterns. Okay, and we can also do some here. Yes, you can see now it has been mapped to the target net, and you can edit this length tuning. Okay, and you can even adjust this the different corner style. So you can do the same way. Even you can increase pattern. So you can able to play. That is again to the net tuning of net with the relative net inside the alternate with help of the design rule. Now let us go back to the presentation. Altium Designer has added into the board data a new health check feature that is focused on improving the reliability of your PCB manufacturing and assembly. In addition to the design rule check, it performs a series of checks on various tools and alerts you to possible problems on the PCB. This can be things like having a zero area region on your board, microsegments are having 360 degrees rotation of a component as opposite to have just saying 0 degrees. All phone problems are organized into categories and include a badge specifying the severity of the problem. And if you try to export fabrication files while a serious violation exists, a warning window will appear with a list of existing problems as well as suggestions for how to fix them. The process of fixing violation is pretty straightforward. Each violation entry also doubles as a link, zooming in and highlighting the error on the board, which makes the error easy to find and fix. And for certain violation types, Altium is able to fix this automatically. And the next Altium with the help of CAD Code Designer is something Altium had for some time. And for those who are not aware, the CAD Code Designer allows Altium Designer users to seamlessly push and pull designs data between the electrical and mechanical domains. This is not just transforming a step file between the two softwares. What we do is actually build the design in the mechanical tools native file format, and Altium do this by utilizing the Altium Design 365 server. Both the ECAD and MCAD tools connect to Altium 365 server, which facilitates the file exchange. Both electrical and mechanical engineers stay and work in the tool they know, understand, and use every day. Now, Altium has supporting integration with Siemens NX, which is possible through enterprise level subscription. If we have a standard subscription or a pro subscription, we can able to collaborate with SolidWorks, Clio, or Discriminator, and Fusion 360. If we have an enterprise level subscription, apart from this SolidWorks, Clio, Inventor, and Fusion 360, we can also push to Siemens NX. Here, I'm just highlighting NX is supported if we have Altium 365 enterprise level subscription. Okay. And another new extension added to the Altium Designer is Power Analyzer by Keyset Technologies. There is a new extension application for Altium Designer user interface that gives designer sophisticated power analysis capabilities without any specialized training. With just a few clicks, you can quickly identify and solve power issues during the PCB design process. Quickly locate, understand, and resolve power issues without relying on expensive prototypes, complicated tools, or simulate specialists. Currently, Altium offers PC analysis, and in the future, Altium has planned to offer AC analysis and more. Understanding the power structure is extremely important and helpful for proper PCB designing. The power distribution flow can be understood from a schematic or board, but sometimes it does not provide enough clarity. Power analyzer in Altium Designer automatically breaks down the entire input power system as a clear and readable tree with all necessary details. It shows the position of a circuit in the overall power structure and allows you to easily and quickly navigate to where the voltage originates from, what is it passes through, where it goes, and how it is distributed on your board, allowing you to locate any element of the power system with just one click. Power Analyzer has a heat map displayed that gives you the ability to pin out problem areas on the board. Reading the heat map is easy and for any level of user with results displayed directly on the top of the PCB. So there is no guesswork. Using the properties panel, you can manipulate the heat map, setting up limits and displaying the current direction. Like with current density map, you're able to display current flow direction and adjust the scale of your heat map. Also with the voltage drop heat map, there is a visual slider for voltage contour. When enabled, it displays the location of the heat map where the voltage is equal to specified voltage contour points, allowing you to especially identify those locations, which can help with the placement of demanding components. When it comes to power analyzer functionality, there is a lot more than what we have spoken out about. We can do a whole webinar on this topic, but we will come up with a webinar in the upcoming days to give detailed presentation about the power analyzer, which is powered by a Keysight. Now we are going to discuss about coming soon inside the Altium Designer. Now, RF design, Altium Designer currently has ability to create multiple designs, and with new RF design capabilities, Altium is able to define the connections between them and other peripherals. To create these RF designs, Altium has added a new product type as well as some new types of files. We have a wiring diagram where individual wires and cables are placed to create the required physical connections within the harness. There is also a layout drawing where the wires and cables are arranged to represent the physical connections of the harness. A viewer document which contains the harness connections, and also a manufacturing drawing which has views from the previously mentioned wiring diagram, layout diagram, and BOM. Any additional information required for the manufacturing of the harness can be added. As currently this harness design is in the beta, I don't have a demo to showcase you. I will show you a video. Let me reshare it. I will just going to use
devices. Use the data from it. Just completed your multi-board project. So what's next? The answer is harness design. This release of Altium Designer introduces new design capabilities in the form of a harness project. Now, you're able to develop harnesses and cable assemblies for your devices. Use the data from a multi-board project to form connections between the connectors. Assign a wire to each connection, specifying the necessary parameters. Specify design features such as stranding, shielding, or the use of a prefabricated cable. In a separate document, the wires are allocated to the branches of the harness. Here, you can specify branch lengths and arrange marking elements. When everything is ready, use a draftsman document to prepare a detailed drawing and generate connection tables. All this will allow you to easily yield high-quality manufacturing results for your assemblies. And of course, the active BOM document will automatically track all the necessary items for purchase.
Yes, this is all about the art design. And next feature, which is we can expect in the coming days, is the new variant manager. The variant manager in Altium Designer has been redesigned and now takes a new approach to how variants are created. Now you are able to create component groups based on schematic documents, sheet symbols, and component classes. You can then configure variants with these groups. This gives make creating variant much easier, especially if you are dealing with several variants in a project. Now let us see how this new variant will help you in creating variants in the groups with a video. As I told, I don't have access to this version. I'm just
Designer offers both a new and legacy approach to design variants, where you can assign each component one of three states: installed, not installed, or replaced. The new variant manager's full power is realized with component groups. Groups are preformed on the basis of schematic sheets, sheet symbols, or project component classes. Once a group is formed, a list of its components is created, and you can start to configure the options. Each option defines a particular state of the component group. For example, there can be differences in available interfaces due to installation of an incomplete set of components on the board. For convenience, groups and options are given names that reflect their content. Thus, each feature generates its own separate group of components. Variations of this feature are represented by options of the group. Variations by assigning alternative components are also available. Formation of groups for each feature is needed when creating feature variants of the project build. When the groups and options are set up, the variants are constructed in a separate table by combining group options. This approach greatly simplifies and speeds up the process, especially in large projects with a large number of options and a complex system of organization. Dozens of variants are created in a few minutes, and you can clearly see the defining characteristics. As always, changes are available for viewing in 3D. This new approach simplifies not only the formation of variants, but also their editing and support as the project develops. Adding components to a group is automatic. For example, for a group based on a schematic sheet, when you add components to that sheet. New components in the group get into the options table. All you need to do is configure their status according to the available options, and that status will automatically apply to all variants.
This is about the upcoming feature about the new variant manager inside the Altium Designer. And earlier we spoke about the ANCAD designer and how it allows for PCB design data transfer between ECAD and ANCAD domains. Now, one of the new capabilities is the ability to do with this multi-board design. You can able to push your multi-board designs also to ANCAD designer, which you can expect in the next releases. And the next feature is by accessing your Altium 365 workspace through your web browser. One other thing we are able to do is viewing your designs. This is available now, but for single boards, but you can't view multi-board assemblies, but soon viewing and interacting with your multi-board assemblies will be possible in the upcoming release. Yes, to summarize today's topic, we discussed about the how we can able to assign the tasks and how we have shown you the comparison, how we can create the custom patch shapes, and we have discussed about the upcoming features inside the Altium Designer like harness design and new variants, and as well as the multi-board support to the mechanical tool and by using mechanical designer and multi-board viewing capabilities in the Altium 365. In addition to the train test features, there are the upcoming releases which Altium has planned, like task manual comments, harness design, and three viewing capabilities, footprint parameters. These are the new features which you can expect in the uh, next releases. Yes, we are open for the questions.